Hello and welcome back to Mr. Saiso's YouTube channel, and today I'm gonna continue my work under Fusion 360 with doing the base plate for the stepper motor. This is the one for the shoulder part, so to say, of the robot arm, and I can show you how far I've done right as of now. Just like this. And so what you see, the long holes are for the bolts. So if I want to build it for the use of a timing belt, that can be done. Also, if I want to use direct drive with gears, etc., then I can use that as well and just more or less push it in place. And yeah, as you have noticed, I have not made any holes for the shaft itself. I will do that momentarily. Also, since this will be done upside, it will be underneath it. I also need to make sure the ring here also has so it can follow, because I want it to be flush against the plastic, so it should not be able to move anything a, a bit at all. So yeah, also I'll be looking at parts for it, as well as making a list for spare parts for the 3D printer itself. I have been 3D printing quite a lot lately, so I've been making started making a stand for the camera, for the webcam I'm using currently. So I wanted to have a live feed when have a live feed when I'm actually making the parts. I suspect it will take a rather long time, and I will control the entire thing through YouTube Studio. So I have an app downloaded to my mobile phone, so I can control it even if I'm at work, which is rather good. I have also added a filter between the extruder and the filament, because I noticed that it was starting to pick up dust particles. So I don't know if yeah, you can see here, there and there. It's not paint or anything. It's actually minor dust. I can sand that out, of course. And I've been trying different, what's it called, fill-in infills. Yeah, infill patterns as well. And I will even start to fill around with walls, top, bottom, uh, etc. We can take a look at it momentarily when the when the first part I want to create is done in Fusion 360. I just want to take a look and see how long it will take for me to 3D print it. And most likely I will have a stand ready for the webcam. I don't know if I will buy a separate webcam. I have to look into that as well, because this is not a 4K high definition camera. Also, it has a very short cable from the camera as well, unfortunately. So yeah, and what else? Yeah, I also have to look into bolts, etc. I mean, this one already has bolts, but for an example, if I take one of let's see, the NEMA 17 smaller bolts, of course, it will have screws or whatever. I want mine to be hex type for Allen keys. Those are the best. Also have um, nuts for them as well, so I have to look that up. Um, can see if we have anything at work that we are going to throw away. I can just salvage it. I mean, free is always better than paying full amount for something. And also I have to look into how to control it. Of course I want to have it controlled via an Arduino, which I have one, and of course nothing is better to have two. Okay, this one has actually a control unit for servos for another robot arm. If you have seen the video, it's a separate video. Pardon my voice, I have a slight cold and a throat pain. So yeah, and so yeah, let's make shit happen. And yeah, I just have to measure everything. So and yeah, we'll just take a look and put on some royalty-free music I have made myself in the background. I don't know if it can be, if it will be recorded even. Anyway, so yeah, let's get back to Fusion 360 and take a look at what I have done so far. Swing it around. Ooh. Yeah, so these are the holes for the mounting screws. Yeah. And this one is the center if I choose to make something different. Perhaps I want to have it go through the hole directly, but then I also have to make holes out here for the, let's see here, we have, yeah, there, we have there. This sketch number 3. This is the exact measurements between each 4 screw holes, plus like 1 millimeter extra, so um, I have a little bit more to grab onto. And as you can see, they are very, very much level inside of it. Just 47. Should be 46 point something. I made it 47, and the holes are a bit bigger as well. They are, or if it's 46.5 or something. The holes, I made them 5 millimeters in diameter. Um, so it will be, I think it will be good. I think it will be fine. Everything. And the thickness, we can swing it aside. Yeah, 8 millimeters thickness. And so yeah, and let's see if I can get the schematics up again for the yeah, this is Swedish site. I need to order ball bearings. Actually, believe it or not, it's also take a look at this later on. And okay, That's not good. I need to find out ah why why. See if I've downloaded it. Perhaps I have, perhaps I have not. No, yeah, strange. Thought I had downloaded. Okay, well, we'll take a look again. I have to just type in the CI24H S2401 dash O3N, and yeah, that sheets. So see if we can find anything for it. Yep, excellent. And could just measure from the wall. Let's see here. Bad idea, I suppose, but anyway. So 27 millimeters in, about. Ooh, a bit tired. Okay, let's get back to Fusion 360, right? Shall we? See if this one was the correct size. Yeah, so we use that one. And we're gonna make a so. I think we'll start from say this line. Oh, oops, oopsie. Make one from this line from here down to say there about. So for me this is just a guiding line, uh, and we'll have no, we'll not make it. We'll make an arc, center point arc. We'll do it from here. 2.5, and we'll just go 90 degrees down there. Oops. See now where we did it wrong. Oh yeah, it has to go the other way around. Yeah. Stupid, isn't it? So we just do one like this. Take it to 2.5. So we can take it down a bit. We do like this from this side, okay? So center point 2.5, and we go all the way 90 degrees. And voila. Do one more. So just do the same thing over here. We'll it's better to have a bit of extra margin, just two, because in case of, you never know if it's needed or not. Wait. Uh, so and now we can remove this center line. It's not needed anymore. No, hang on a second. Wait, now. Wait a minute. It's more. Okay, that's 6.3. Okay, so let's say 7. So 3.5. We'll redo everything. Go back and make the arc again. Right, so that's better. Go down and do the same thing down here. And we have to make it 3.5. 90-degree turn or so, yeah. Arc again. Midpoint 3.5, right, and back there. Excellent. Now, however, we can remove this line. It's not needed anymore. And just zoom out of it all. We see both lines. All right. Take this line, put it there. Ooh. Okay. So finish sketch. Done and done. So let's put it this way and mark this one up. Extrude it in the opposite direction. 4, 5, 6, 7, and 8. Right? Okay. So And of course we can't forget to make a mounting holes for it in the middle if we choose to make it a direct drive to a cycloda gear or whatever. And remember, it's quite long, this entire piece. I can just measure. It goes from, oh, let's see here. Yeah, hang on a second. I think it's, and okay. Uh, anyway, it's about 200 and something millimeters in length. So we can just do it like this and measure. So 121 to the beginning of the middle of the hole. Let's see, take that times 2, 21, plus 6. Alright, so plus 7. So 240. Let's say 250. I think, now I'm not 100% sure, but I think the printer should be able to actually print this piece. If it doesn't print it flat, I can also put it on a slight slant and make support. A tree branch that goes out just like 20 degrees up a bit. I think it should do it. It would have been really, really great if I would have had my hands on a milling machine or similar to make everything in, yeah, well, aluminum instead of plastic. Nothing wrong with plastic, but uh, so I will make this upside down actually. So this part is uh, 30. How much is it? 30, 38 millimeters in diameter. We'll just put it in the middle of this. Uh, Same here. We'll go in the middle of this. And yeah, first things first. We need to do the holes here. We'll place this in the center. Okay, so we have this sketch. I don't know if I can move it. Let's see if we can move it. I don't know. Can we? Oh yeah, we can move it. Excellent. Man, that's just great. Ooh, I think that should be in the middle. Uh, More or less. Maybe. Does it look like it's in the middle? It does, doesn't it? Um, See now, if I want to make the holes for this, now it's quite straightforward. I just, okay, hang on a second, we just do like this, and then we, this, select this one. Okay, hang on a second, just get it. So, and then we have, one, and we'll make one more, alright. Hang on a second, this music you're listening to right now, if you can hear it, is not uh, put on some other music that's royalty free, so this one. Okay, so just remove that one. And there you go. Nice. Very nice, very nice. Finish sketch. So now make... we have to... oh, not so much. Now made holes. So, now we make this one. So it's... okay. Make a sketch again. I mean, this is just fun, isn't it? So, we'll make... how much did we say? So, 38. So 38.1 or 38.2, even better. We have a bit of a margin. 38.2. And voila. So finish the sketch. Another question that remains is how deep to make this. It will not be so very deep. I suppose it will be 2.5. Let's make it... no, it's 1.5 millimeters even. So make it 2 millimeters depth. Right? Ooh. That's the depth it should be. I'll just make it a bit more. Wait. So. And okay. Now looks something like, hang on a second. Looks something like this. And you know what? That's just good enough for me. So now we have to do the same here, except it has to be just like me. 15.2 millimeters radius about. Uh, should actually go to the middle. Man, I don't know, make it in the middle then. I could see now. I'm not so good with Fusion 360, uh, and this is a bit of a challenge actually right now. I don't know how to. Uh, yeah, so I've placed in the middle. Yeah, it has come out a bit. So what did we say? We made it. It is 38. We made it 38.2. So right. Uh, see, 38.2. Oop, point 2 divided by 2 is 19.1. Good. So now we actually have a figure to work with, and half of 19 point. What did we say? Half of 19.1 is half of that is 9.55 millimeters. Will give us the radius of this from that point to this point. Or no, it won't, but it will do half of it because that's how I made these. Okay, so all right, let's make it. And I don't know if it will intersect screw holes. No, it won't. It will just give a margin more or less. So what we do is we'll make, so we have to work with. Okay, so we have one line there. Great. Now we just make one more line. And we make it from here. Make it just as long as that one up to this point. Okay. Now, now we'll see if we can make the arc. It's a 3-point arc. Okay. So 9.55. Ooh, okay. That did not go as planned. Okay, let's try again. Um, center point arc. Okay, there. And we'll just zoom in. Okay, I think you have to go for 9 point. Okay, so 9.55. Okay. Think they are a bit too long out. And yeah, hang on a second now. What if I just make the entire thing? So what was it? 38.2. Okay. Ooh, it would be very, very big. But it would be further down. That's why. Okay. Okay. So yeah. Okay. Now hang on a second. I think I got it now. Hang on a second. I think I know what I have done wrong. It must be specified from this point in middle. Yeah, because that's the middle of this. Get it? Okay, and let me show you. Hang on a second. I can remove this actually, and I'll remove this as well. I don't need them. What I'll do is make the arc, center point arc, and the center is here. And 9.55, and just down here. So look, so no, hang on a second. Nah, that's not even close. What the hell? Okay, let's go back. Let me see here. Okay, 19.1. We make 19.1. Okay, hang on a second. Make it even bigger. Uh, yeah, there. 19 point, no, point 1, point 2, point 1. Yeah, gotcha. Now we get it. So now we make next. See, I will just escape on that one. Arc. Center again. How high? Up there. Down there. Nice. Let's see. Hang on a second. I just need to. Right. Oops. Uh, Hang on, I want to hear this music from the start. It was quite good actually. So, okay. Uh, Back to the drawing board. Okay, and the mid. Yeah, the radius is 19.1, not 9.55. That's half of 19.1. My mistake. Okay. And depending on what stepper motor you're using, you have to take into consideration if it has a. This is high. I think this is even high. Yeah, this is two millimeters depth and 22 millimeters diameter. So depending if it has like this little lip or whatever you want to call it, you can either make a plate, goes onto it, and then into the model arm you're making. Good tip. So let's do this. Center point up to this and down. Here we go. So excellent. Now we do the lines. Okay, this to this, right? And then we take next line. This to this. So escape, finish sketch. Yep. Now that one also has to be done a bit. And what did we say? We make it 1.5, so make it 2 millimeters depth. Okay, let's zoom in. Imagine having a better 3D printer like a Snapmaker. You can etch things also, such as laser engraver, etc. Never mind. Uh, so this will actually be from the inside, so it will go this way into the plate itself. This is for the long hole, and this is just if you want to mount it directly in the middle of it all. And now we have to actually have to do one thing more. I have to actually know how because I wanted to be round, and then I make like legs sticking out, so it will give it a bit. It will be a bit more sturdy, and you can bolt it on to say a piece of wood or metal or whatever. Perhaps make some clamps and clamp it onto a table. Let's see here now. I have to somehow figure out. 250 millimeters in diameter. Okay, so I should be able to do um, should be able to make it into the 3D printer. We can test actually. We will do like this. We'll export it. Let's see here. To like this, we know what we are building all along. So and right, so we have Ultimator Cura. It's just oh yeah, it's too big, correct. However, we can, let's twist it around a bit. First of all, we have to do it like this. So you see, now it can fit inside the printing and we'll make sure that the let's see here, those come down somehow. I want them to be further down. Printer settings. Okay, you know what? I need to. Oh, hang on a second. I don't think you guys are seeing this. Give me a second. Give me a second. No. You can't see it, can you? Why? Wait, why can't you see this? Now there. So, yeah, now you can see it. So, the thing is, I need to set up in how the printer settings for it, and I think it's 300 times 300, and I can't remember the height of it. If you give me a second, I just figured that out. Let's see here. Three hundred times 400. Okay, so yeah. Let me give it bigger. So, okay, now do like this. Clear build plate, right? Put the So now it looks much better. Um, so this is how it will be. I could raise it a bit. Uh, so quality. Well, actually, I'm gonna have a and we will have infill because this should be able to handle a bit. I will not be using um, ordinary filament. I will be using PETG. So ordinary, I don't know, cross 3D gyro. Which one is? Using material cost, grid triangle. Gyroid, cubic, quarter cubic, and octet infill and change with every layer to provide a more equal distribution of strength over each direction. Lightning infill tries to minimize the infill by only supporting the ceiling of the object. Well, shall we start with gyroid? So where do we have that one? Let's see how many hours. Ooh, 9 hours. Uh, which other? Quarter cubic. Okay. 7 hours. Okay, that's better. So 200 gram and 67.15 meters total of this. I would need to order more filament, and that I'm sure of. It will be, I think it's a darker gray color. And okay, 7 hours, 19 minutes. That's quite okay actually. And if I take standard quality, 6 hours, 18 minutes. But I want best quality. Okay, so let's go back to zigzag. And let's see how many hours if we do there. We'll do 6 hours also. So yeah. So the question that remains is how would we proceed now? Proceed by making more parts. So this part is done, so we can close it. So we'll do next part, and that's the surrounding of the base plate. So we know it will be 250. Start by doing a sketch again. And height of it, yeah, see now that's the big issue, isn't it? So this is around 55 millimeters almost. I think it said it's around 54, correct? 54. And whether or not it will have a support beneath it. No, because the roof, the seating I have made first, the base plate should be able to hold it. So we'll do this, we'll make the walls a bit thicker. We will also we may need to make sure that it can be bolted down into the let's see here. Oh, hang on a second. You don't see what I'm looking at right now, do you? No. So this is what I'm looking at. This is the measurements. It's the 24HS2 asterisk asterisk. So 54 millimeters about in length, give or take. 2.13 inches. You can see the. Right, I think we can see the complete data of the. Can just. Yeah, it runs on 24 volts. Actually, that's good because the power supply is feeding 24 volts. And the drivers can handle up again. I think it's 36 or 35 volts or something, and deliver power. Yeah, I also need to make sure that these come in there as well. So say 250. So that's 25 millimeters. 25 centimeters, I mean. So I will have much space, and then question is how high should it be? If I take into consideration I want the power supply unit to be inside of it. Also cooling. Do I want all of the drivers to be inside? Yes, no, perhaps. Do I want from the shoulder and up? Go back to the let's see here. Switch back to the project. So if, say for an example, I want two stepper motors to be here, then I have to actually order one more driver, because then I have more torque, more power to, you know, have the arm go this way. So yeah, that's pretty fun. Let's see what we can do about it. Step closer to everything. So this is 54. I can make it say make it 120. Then we have could make it 150 as well. And then we also have to take into consideration I want it to be rather thick inside. I think the power supply will be on the outside actually. I will make its own holder or small box for it, ventilation, and power supply unit. Right, so okay, do this. So shall we say 120 was rather, we'll take it minus 5 millimeters. 5 millimeters thickness should do. 40. And then we come up to this point up here. Perhaps it's too much, but I could say to make 110 millimeters. And I think perhaps I can fit all the electronics inside it. The thing is, I want the Arduino as well. The Arduino is, let's take a look and see how long it is. It's 100 and so we make it cylindrical. So we just make a cylinder out of it. We make it 120. Do that. So yeah. So then it will stand on something that's 5 millimeters in thickness, and that's about much. I think it will do. Now we make the plate underneath it should stand, and we make that one thicker. We'll make this 120 anyway, so that's because then we have a lot of headroom to move things. We can have this underneath for an example. And then we have let's see here. We have then 75 millimeters, give or take. So 100 and if we give it 110 millimeters, then have okay, make it 110. We can fit some electronics also in the inside, perhaps. Because it will be 240-ish. 250%, yeah, right. So there, and half of that it will be 125. Oh yeah, we will be able to fit electronics inside of it. Against the wall, have ventilation. This will be quite good. Because if it's too tall, it might, you know. So I think 110 perhaps will do. Because just lock it in place, because it will stand up also a bit there. So let's say minus 5, so that would be 105 millimeters. Oh yeah, that's good enough. These get rather warm, just so you, if you don't know about stepper motors at all, or 3D printers. Okay. So what did we say, 110, okay. Right, so now comes the fun part. so we want the wall thickness to be around 5 millimeters. It is 250. Let's see, let's take out just 250 minus 5. Should perhaps make them a bit thicker. I mean, 5, we can make it, say, 7. You know what? Let's make them the thickness of the walls. Make them 8 millimeters thick. Yeah. So 242. We'll remove 242 from the middle. Right. So. Leave 8 millimeters remaining will be good enough. Yeah, do so. Now comes the fun part. Oh, what did we say? Ventilation? Of course. We want ventilation. Remember now, we can actually do some cool lines. We won't make them horizontal actually, we just make them in like this. Right. So